Huwag kayo iiyak.
Hi guys, we are the 5Ds. I'm Juan.
I'm Jade.
God gave me you to show me what's real.
I'm Jade.
Itanong mo sa akin kung sinong aking
I'm Jerel.
Para sa'yo ang laban na to.
I'm Jose.
Ikaw na nga ang hinahanap ng buhay.
And now we are going to talk about the shear and moment diagram.
Let's clarify what exactly shear and moment are. Shear refers to the force that acts perpendicular to the longitudinal axis of a structure, causing it to slide or deform. Meanwhile, moment, also known as a bending moment, it is the tendency of a force to rotate an object about an axis. Why are these diagrams so important? Well, they basically show us where and how much these forces are acting within a structure, which is crucial for designing safe building and bridges. Building these diagrams might sound complicated, but it's actually a step-by-step process involving some math and plotting. Once you get the hang of it, it's not so bad. And the best part, once we have these diagrams, we can see exactly where the structure is under the most stress. This helps us design stronger and safer buildings. In many structures, beams are critical components that must be carefully designed and analyzed to meet structural requirements and safety standards. Beam refers to a slender bar that carries transverse loading. That is, the applied forces are perpendicular to the bar. There are a lot of types of beam, such as simply supported beam, cantilevered beam, overhanging beam, and concentrated load. Rollers are often used to allow movement along a linear path. In beams, rollers are typically installed at support points or where the beam meets another structure. Pins are used to allow rotation or pivoting at a specific point. In beams, pins are often inserted through holes drilled in the beam and the supporting structure. The sign of convention in structural engineering is like a rule book for showing the direction and strength of forces and moments on a beam. It's crucial for accurately drawing shear and moment diagrams.
Hi everyone, I'm Jerel and I'm the one that's going to be showing you the shear and moment diagram for both the equation method and the area method. So, as you can see here in our paper, makikita nyo that here's the given beam. So first and foremost, kukunin natin is the forces for both AY and DY. So the most simplest method here is just summation of forces. Vertical is equals to 0 and upwards is positive. So AY plus DY is minus 2. So this is 5 meters. This is 3 meters. This is 2 meters. So minus 2 multiplied to 5 and minus 10 because they're both downwards equals 0. Now transpose the two values to the other side. So AY plus DY is equals to positive 10 and positive 10. So AY plus DY is equals to 20. So to eliminate one of the forces, we just have to summation of moment at either A, at point A, or at point D. So for us, gagawin na natin is we will summation our moment at point A. So summation of moment at A is equals to 0. Clockwise is positive. So So for the first force, it's for here, okay? So it's positive because it's clockwise, so 2 multiplied by 5, and the middle is 2.5. The next is the 10, it's also positive, so plus 10, and the distance is 8 meters. You have to put the meters. And then for dy, it's a counterclockwise, so it's negative dy, and it's 10 meters. So 10 is equals to 0. So you just have to transpose dy. So 10 dy is equals to 10 dy is equals to 2 multiplied by 5, 2.5 plus 10, 8. So it's 105. So to get dy, just divide it by 10. So dy is equals to 10.5 kilonewtons. So based from your answer, you can just use this and use it on the first equation, which is this one. So ay plus 10.5 is equals to 20. So ay is equals to 20 minus 10.5, which is ay is equals to 9.5 kilonewtons. So now that we have the two unknown forces, we can just put it at the side. So dy is equals to 10.5 kilonewtons, and ay is equals to 9.5 kilonewtons. So based from that, we can just erase this for now. We can erase all of this. There you go. So next is we have to cut the beams into 1, 2, 3 parts. So 1, 2, 3. So there are 3 segments here. So we just have to solve the shear and moment for segment AB, segment BC, and segment CD. Right now we're doing the equation method. Right after this, we're going to do the area method for the checking. So segment AB, so it's better to draw the FBD, the free body diagram. So here VAB and moment AB, and then here there's AY, which is 9.5 kilonewtons, and then draw the load, which is 2 kilonewtons per meter, and this distance is unknown. Okay, so first we have to summation of forces vertical equals 0, upwards is positive, so negative VAB plus 9.5, which is AY, and then minus 2, and because it is unknown, we just have to put X because it is a load. Uniformly distributed load, so equals 0. Now transpose VAB. So VAB is equals to 9.5 minus 2 multiplied to X. So this is the first shear for segment AB. And then next is the moment. Summation of moment AB is equals to 0. Clockwise is positive, so minus MAB. And then here, so AY is positive plus 9.5, and the distance is X. Then next is the 2, so minus 2 X, and then the distance is X over 2 because it's half here. See, X over 2, so equals 0. Now just transpose MAB. So MAB is equals to 9.5x, and divide this, so you can cancel this. So negative x squared. So this is the moment for AB, for segment AB. Now, next is the segment. By the way, this is 0, less than or equal to x, or less than or equal to 5. Now for segment BC, we will just start at the last number here. So it's 5 less than or equal to x, or less than or equal to 5 at the distance here, so which is 3 meters, so it's 8. So yeah, and then here we have to draw the FBD again. So VBC and moment BC. But now we know that this is 5 meters and AY is here, then the load is here, so this is 2 kilonewtons meter. Is this correct? Yes. And then this is x, all of this is x. Then here we just have to minus 5 to x, so x minus 5. That's the distance here. So same as we did for segment AB. Summation of forces vertical is equals to 0. Upwards is positive. So minus VBC. Then plus 9.5. Because we know the distance here, we can do minus 2 multiplied by 5 is equals to 0. Transpose VBC. VBC is equals to 9.5 minus 2 multiplied by 5, which is negative 0.5. This is the shear for segment BC. Now next is the moment. So summation of moment BC is equals to 0. Clockwise is positive. Now negative MBC. Then the distance for AY is x, so plus 9.5x because it is clockwise. So you can see clockwise. So next is the 2, so minus 2, but we know the distance at the bottom, so it's 5 meters. And then the distance from here to here is, so x minus 5 is up to here, and here is 2.5. So we can assume that this is x minus 2.5 because wait, let me explain it again. So here is x and here is x minus 5, right? Because this is 5 meters. This part is 5 meters. So what we have to do, we just have to cut it in the middle. So this is going to be 2.5 meters. So based from that, so x minus 2.5, this is x minus 2.5. We just have to minus the 2.5 to x. That's why this whole part is x minus 2.5. Okay, wait. So the distance is x minus 2.5. Wait. So 5 and x minus 2.5 is equals to 0. Now I just have to transpose MBC. So MBC is equals to 9.5x minus 10 x minus 2.5. I got 10 from 2 times 5. Okay, now we have the moment for segment BC. Now for the last segment. So for segment CD. So for segment CD, so this is B, this is C, this is AY, This is 5 meters. This is 3 meters because we already know this, that this is 3 meters and this is 5 meters. And this is VCD. VCD. Uniform load. And there's an additional force here, which is 10 kilonewtons. And this is the whole unknown distance. This is x. So from here to here, same as before, it's x minus 5. But in here, from here, it's x minus 8. Because 5 plus 3 is 8. And 8 minus 2x. So you get the distance here, x minus 8. And then same as here, same as before, this is going to be x minus 2.5. Okay? So same as before, summation of forces vertical is equals to 0. Upwards is positive. So minus VCD. And then plus 9.5. Plus 2 multiply to, 2 multiply to 5. 5 and wait, it's not plus, it's minus. Minus 2 multiplied to 5 minus 10 because it is downwards equals 0. So VCD is equals to negative 10.5, which is same to our dy. As you can see, it's same to our dy, so it's correct. And then you have to do this. So this is the shear for VCD. Now summation of moment CD is equals to 0. Clockwise is positive. So from that, it's the same distance for before. It's the same distance as before, but there's just an additional 10 kilonewtons. So we can just copy the one that we have here above, but I can just show you the solution, which is MCD. AY is 9.5x. Same as before, negative 2, 5, and x minus 2.5, and then the additional 10 kilonewtons, which is minus 10, and the distance, as you can see there, is x minus 8, equals 0. Then transpose MCD. MCD is equals to 9.5x minus 10, x minus 2.5, which is same here, as you can see. Then the additional negative 10, x minus 8. So that's for the whole equation. Now for the drawing of the diagram, first you have to substitute the numbers here. So 0 and 5, 5 and 8, and for segment CD is going to be 8 less than or equal to x less than or equal to, which is the final number, 8 plus 2 is 10. You just have to substitute those numbers to x here. So wait, so I'm just gonna put a line here. Substitution of values to x. So first is segment AB. Segment AB. So I'm just going to go above. Segment AB is 9.5. So V is equals to 9.5 minus 2x, and moment is equals to 9.5x minus x squared. 9.5x minus x squared. And then for segment BC, shear is equals to negative 0.5, so there's no x here. And moment is equals to 9.5x minus 10, x minus 2.5. For segment CD, V is equals to, shear is equals to negative 10.5. There's no x here as well. M, or moment, is equals to 9.5x minus 10, x minus 2.5 minus 10x minus 8. Okay? So we just have to substitute the values. So for segment AB, it's 0 and 2. For segment BC, it's 0 and 5. Wait, let me correct that. 0 and 5. For segment BC, it's 5 and 8. For segment CD is 8 and 10. So for here, I have to do is, so segment AB 0, so V is equals to 9.5, moment is equals to 0, and then segment AB, when it's 5, V is equals to negative 0.5, the shear, and then the moment is equals to 22.5. Then segment BC, when it's 5, shear is also negative 0.5, moment is equals to 9.5 same as well, it's 22.5, segment BC, when it's 8, so shear is still the same, negative 0.5, moment is equals to 21. And then for segment CD, when it's 8, shear is equals to negative 10.5, moment is equals to, it's the same because 8 will just cancel out here, as you can see. 8 is gonna cancel out here, so it's the same, it's also 21. So segment CD, when it's 10, the shear is still the same, negative 10.5, and moment is equals to, so 9.5 multiplied by 10 minus 10 minus 8, so you get 0. So these are all of your values for equation method. There you go.